Now, the easiest way to describe an equation is in terms of algebra, but sometimes we choose to describe an equation in words. When that happens, we need to be able to take those words and translate them back into the equation. So suppose we're told the product of 5 and 3 less than a number is 9. Now, this is very similar language to the language that we used to describe expressions, but there's an important difference. When we described an expression, we just used a phrase. When we describe an equation, we use a complete sentence. In particular, there is a verb in a description of an equation. So whenever you see a phrase or sentence that appears to be describing either an equation or an expression, your very first move should be to look through and see if you can find a verb. And the verb in this sentence is this word is. It's just is. That means that the verb in our math sentence is going to be equals. Now, one side of the equation comes before is, the other side comes after is. So that's our next move. We divide the sentence into two parts. Is 9, that part's easier to deal with, so I'm going to deal with it first. I know the right side of my equation is going to be 9. Okay. The left side of my equation is this whole long clause here. And I parse this just like I would a description of an expression. It says the product of blah 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 and blah blah blah. So this and goes with this word product. I know that I'm going to have multiplication. Now I need to figure out what the two things are. Right? So I'm referring to that and. 5 and longer phrase. So 5 and 3 less than a number. 3 less than a number, that means whatever letter I like, minus 3. And that's it. That's all I need to do in this problem, because I'm not asked to solve the equation. How would we ask you to solve the equation? Well, we would ask the question, what is the number? If we have that question, we want to solve this equation. 5 times x minus 3 equals 9. To do this, our first move is going to be to distribute 5x minus 15 equals 9. Right, remember this means plus negative 15. To get rid of that negative 15, we'll add 15 to both sides. 5x equals 9 plus 15 is 24. Now we'll multiply both sides by 1/5. The 5 and the 1/5 cancel, and we just have x equals, this is going to be some sort of decimal. This looks like a job for the calculator. 24 times 1/5 is 4.8. Okay. So what is the number? It's 4.8. Let's see one more example of this. What does it look like when we're describing an equation that has variables on both sides? Say we're told that twice a number is 9 more than half of the number. Again, our first move is to look through for a verb, and we find the verb is. So this phrase over here describes one expression, this phrase over here describes the other. Twice a number, that just means 2 times our number, is 9 more than half the number. Half the number is half x. So here, because it said 9 more first, we know that we need to add in the 9 and then multiply by a half. If it had said half of 9 more than a number, that would have told us that it was half of x plus 9. But here it says 9 more than half of the number, so we multiply by a half first and then add 9. Okay, to solve this, first we need to get all the x's on one side. I'm going to subtract half x on the right, because remember, I need to get fewer terms. The only way I can change the number of terms is by adding or subtracting. So here I have 9. Here I have, let's see, 2 minus a half is 1.5. 1.5x equals 9. I'm going to multiply both sides by 1 over 1.5. These cancel. I'm left with x equals 9 times 1 over 1.5 is 6. Right, the number is 6. And that's all there is to these. It's just a question of first recognizing that is tells you that you have an equation, and second, parsing through and finding the two expressions.